You're handed a scary infinite sum and asked one question: does it converge? There are about 7 different convergence tests, and picking the wrong one can burn the whole problem. Here's the secret weapon: one decision flowchart that picks the right test every single time. Let's build it, then run real series straight through it. This is full marks. Today, the infinite series flowchart, which convergence test to use and exactly when. Start at the top with the fastest check, the nth term test. Look at the terms themselves. If they do not shrink to 0, stop immediately. The series diverges and you need no other test. If the terms do go to 0, the nth term test is inconclusive, so move down. Now recognize the shape. Is it geometric? Then it converges exactly when the common ratio is less than 1. Is it a p-series, 1 over n to the p? Then it converges exactly when p is greater than 1. Those two have instant verdicts. Still stuck? Match the test to the structure. If it looks like a series, use the comparison or limit comparison test. If you see factorials or exponentials, reach for the ratio test. If the signs alternate, use the alternating series test. That's the whole tree. Example 1, the harmonic series, the sum of 1 over n, the terms go to 0, so the nth term test is inconclusive. But it's a p-series with p equal to 1, and p-series diverge whenever p is at most 1. Verdict: diverges. Example 2, the sum of 1/2 to the n, that's geometric with ratio 1/2 which is less than 1. Geometric series converge whenever the ratio is below 1. Verdict: it converges, in fact, straight to a sum of 1. Example 3, a real AP question. The sum of -1 to the n over 1 plus root n, the signs alternate and the terms shrink to 0, so the alternating series test says it converges. And because the absolute version diverges, it converges conditionally. Example 4, the sum of 2 to the n over n factorial. A factorial in the denominator screams ratio test. The ratio of consecutive terms is 2 over n plus 1, which goes to 0, far below 1. Verdict: converges. Recap: always start with the nth term test, then recognize geometric and p-series on site. After that, match the test to the shape, comparison, ratio, or alternating. One flowchart, every test in its proper place. Choosing the right test is half the battle. Next, we leave series behind and watch differential equations come alive, a whole field of tiny arrows with solution curves flowing through them like currents. Slope fields next on full marks.